10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Liftoff.
Did you ever wonder what we're made of? We're all stardust. The elements that compose us are actually forged in huge cosmic explosions in outer space. In understanding these cosmic explosions, you have to actually look at them at the very second they ignite. And that's something you can't do with ground-based telescopes. If you want to do that, you have to take your telescopes, put them on satellites, and launch them into outer space. And that's exactly what we're going to do.
ULTRASAT became a project way back in 2019, but the truth is that we've started thinking about it already in 2010, trying to find ways to answer some of the big questions in astrophysics using Israeli technology.
The main motivations of ULTRASAT are transient astronomy. Transient events are rare events. You can't just wait and on a very small region in the sky and hope that you will have that event happening there. So you need to monitor a large fraction of the sky, so the probability of having those transient events are large.
So for ULTRASAT, this was probably one of the biggest challenges, to find an optical design that is capable of providing both the very wide field of view and reasonable image quality.
There are signatures that you can see in the UV light curves that you cannot see in other wavebands, but you must go to space in order to observe in the UV, because UV is not penetrating in the atmosphere.
Specifically, it tells us something about very hot objects in the universe of temperatures above tens of thousands of Kelvin, which is usually the setup in cosmic explosions like supernovae.
By studying these objects, we hope to answer some of the big open questions in astrophysics and in physics in general, like how black holes grow and affect their environment, how stars explode, where in the universe the heavy elements were produced, and which stars are most likely to host habitable planets.
You look at a phenomenon and you say, according to all my theoretical understanding and my previous experience, this thing should not exist. And yet, it exists. And that's what really drives our knowledge forward. Finding the thing that you didn't expect, that you didn't predict, and you cannot explain, at least initially. Because we are taking data that nobody's taken before. Nobody's looked at such images. You know, nobody has these big UV cameras in space. You just cannot take this data any other way. One
of the unique aspects of ULTRASAT is that it is the first major project in which the industry and the academy are collaborating so closely and on such a large scale. The things that ULTRASAT accomplished was to strengthen Israel's international standing. NASA has chosen to join ULTRASAT under Israeli leadership to provide the launch for this mission.
There are very few institutes in the world who have a space research program. This puts us at this very unique and exclusive category that would be a game changer. So we would like to invite you to join us on this really frontier-breaking journey together with us.